Hi, my name is Mohamed and I'm an applications engineer at Maxim Integrated. I've been looking at a few different ways of adding temperature measurement to my homemade smartwatch project. In my previous video, I talked about using the discrete temperature sensor MAX17055. Today, I'm going to be looking at a few different ways of using the battery management IC MAX17055 to do the same thing. Any portable system with a rechargeable battery must have a fuel gauge IC to detect the remaining battery life. As it turns out, the temperature of a battery affects one's ability to estimate the remaining battery life, and it also affects how quickly you can charge a battery. For this reason, most fuel gauge ICs have a temperature sensor. The chip I'm using to measure battery state of charge is the MAX17055. I love it because in addition to its battery monitoring capabilities, it also measures temperature with just a few microamps. It has both an internal temperature sensor and the circuitry to drive an external thermistor, which is a temperature-dependent resistor. It does all the background work so I can keep my microcontroller in sleep mode, and I can just read temperature measurements over the I2C interface. The two demos I'll be doing are pretty simple. The first one will use the MAX17055 to measure its internal temperature and print to a serial port. The second demo will use the thermistor circuitry inside the MAX17055 to drive an external thermistor and print that temperature to a serial port. The boards I'll be using for this demo are the MAX32630 Feather board and the MAX17055G EV kit. To measure the internal temperature of the MAX17055, it's quite easy. There's a dye temp register available. It's factory calibrated to plus or minus 1 degree Celsius over the whole operation range, minus 40 C to plus 85 C. All I have to do is configure the MAX17055 to read from the internal sensor, and then I can just read back my temperature readings. When I first start my program, the internal temperature sensor on the MAX17055 is enabled. Now as I touch the IC, you can see the temperature start to go up. And when I remove my finger, you can see the temperature start to drop. Notice that when I try to touch the thermistor, I'm having trouble reaching the thermistor with my finger, so I need to call in the big guns. Literally. I'm going to be using this heat gun. Kids, don't try this at home. So now that I have my heat gun, when I turn it on, you can see the thermistor start to increase in temperature rapidly. Okay, that's enough. So there you have it. In under 5 minutes, I showed a few different ways of using my battery management IC, MAX17055, to measure temperature. If you want more information on the MAX17055, check out the link below or visit my knowledge base article related to this video. Thanks for watching. I'll see you next time.